Are nitrites actually bad for us? Do you know that they can be a legal preservative for food, but at the same time they can also be harmful to us humans? This case can actually develop more research on nitrite detection, such as sensor and biosensor method. Assalamualaikum and hi to all the panels. My name is Suhaila Atira binti Muhammad Yazid, and today I will present on my review on the recent progress on sensor and biosensor for nitrite detection. This is the outline that I will present after this. Let's start with the first part, which is introduction. So what is nitrite? Nitrite is actually a chemical compound that consists of oxygen and nitrogen. They are totally common in our environment. For example, vegetables acquire nitrite and nitrates from the soil they grow in. Nitrites are also being used in processed meat to prevent bacterial growth. According to the United States Environmental Protection Agency, the limit of nitrite amount in water is 1 mg per liter or 1 ppm. Proceed to the problem statement. There are two problem statements that inspire me to do this review. Firstly, as you can see from the graph, it shows the number of publications on nitrite detection over time. From 2011 until 2001, we can see that there are still limited number of review articles related to sensor and biosensor detection. The second one is the excessive amount of nitrite have many disadvantages, especially to the environment and human health. Hence, detection of nitrite is important to reduce its threat to humans and the environment. Then, let's look at the objective of study. Firstly is to discuss the different conventional methods for nitrite detection. Next is to highlight the sensor and biosensor development for nitrite detection. Now, let's move on to the review part. Nitrite ion is a conjugate base of nitrous acid, and it can appear as crystalline solid or colorless solution. The anion nitrite is a versatile chemical species that has been used in a variety of applications, such as food preservation and dye manufacturing process. However, it can also pose health risks such as cancer because its ability to produce carcinogenic nitrosamine and N-nitroso compound. A high dose of nitrite could lead to a nausea inside the blood, which is better known as a lack of oxygen reaching the tissues or a deficit of oxygen. There are two methods that I will share regarding nitrite detection. Firstly is the conventional method. The other one is sensor and biosensor method. For the conventional method, Spectrophotometric method has been conducted. Generally, the Spectrophotometric method, which is simple and cheap, is the most common method used to determine nitrite. These methods are primarily based on the diazotization or nitrization reaction of nitrite with a detecting reagent, and the absorbance of the product is proportional to the concentration of nitrite. These are the research done using the Spectrophotometric method. Next is Colorimetric method. Colorimetric method uses a colored reagent to determine the concentration of chemical element or chemical compound in a solution. The colorimetric method usually is simple and easy, sensitive with an uncomplicated instrument. It is appropriate for on-site analysis and is commonly used to assess trace elements. Here is the research done by using the colorimetric method. Then, moving on to the high-performance liquid chromatography, which is HPLC. It is one of the available and widely used methods to detect nitrite. HPLC utilizes liquid mobile phase to separate components of mixture, and high pressure is used to push solvent through the column. This is an example of research done using the HPLC method. Besides that, gas chromatography have also been used to detect nitrite. Gas chromatography mass spectrometry has high selectivity and sensitivity. The mobile phase, which is an inert gas, is forced through a column at high pressure. the sample to be studied is vaporized and moved by the gas's mobile phase. This is an example of research done using the gas chromatography method. Nitrite detection based on surface-enhanced Raman scattering, which is SERS, has been extensively studied for its application in the fields of chemistry and biology. Raman spectroscopy is an optical spectroscopic technique based on the inelastic scattering called the Raman scattering of light by the matter, which is the molecule of interest. The enhancement of Raman scattering of molecules adsorb on the metallic nanostructures such as silver and gold in the basis of surface-enhanced Raman spectroscopy. These are the research done using the SERS method. Now, let's move on to the other method, which is sensor and biosensor for nitrite detection. A biosensor consists of bioreceptors such as enzymes, deoxyribonucleic acid, which is DNA, aptamers, microorganisms, and cells. These bioreceptors will interact with the target analyte, causing a physical or chemical change that causes a transducer component to emit a readable signal proportional to the analyte concentration. Firstly, is electrochemical sensor and biosensor. It uses electrode as transducer element when analyte is present. The electrochemical biosensor is a type of analytical equipment that convert biochemical events like enzyme-substrate reaction and antigen-antibody interaction into electrical signal. An electrode is a critical component where it serves as a surface for biomolecule immobilization and electron flow. These are the research done using the electrochemical sensor and biosensor method. Fluorescence sensor is based on fluorescence quenching, fluorescence amplification, or fluorescence resonance energy transfer, which is FRET. The interaction of fluorophores and metal nanoparticles causes the fluorescence to shift. These are the example of research done using the fluorescence method. Next is Nanoparticle-Based Method. A nanosensor is a device that uses at least one nanostructure material to detect gases, chemical, biological agent, electrical field, light, heat, and other substances. The usage of nanoparticles in biosensor considerably improve the system sensitivity due to their large specific surface area, allowing for a greater number of bioreceptors to be immobilized. These are the research done using the nanoparticle-based method. In conclusion, electrochemical sensors and biosensors are the most widely used methods since they can be miniaturized and have high sensitivity. Their detection limit is also lower as compared to the spectrophotometric method. Other than that, spectrophotometric is less preferred as compared to electrochemical because the method is prone to the interference from colored species. The interference from other species could affect the sensitivity of this method. Lastly, based on the review, modifying the electrode with graphene-based nanoparticles in the electrochemical biosensors could improve the nitrite detection because of its larger specific surface area, excellent conductivity, and good electrochemical activity. For the recommendation, future research should concentrate on understanding the mechanism of interaction between nanomaterials and biomolecules on the surface of electrodes or nanofilms. Next, utilizing novel materials to create a new generation of biosensor, such as carbon nanodots. Lastly, the electronic tongue could be an alternative for monitoring solutions with variable inorganic species concentrations in the presence of interfering species, such as chloride, sodium, and potassium ions. More research could be done to see how well the proposed electronic tongue system performs in monitoring inorganic species. Here are the references that I used in the presentation. That's all from me. Thank you.